He was born the same year that Galileo died, a fragile baby, so weak that few believed he would live past his first night. But this frail child would grow up to uncover the laws that govern stars, planets, and apples falling from trees. Isaac Newton didn't just study the universe, he rewrote its rules. England, mid-17th century. The air buzzed with conflict, civil wars, plagues, and revolutions. The old medieval world was collapsing, and a new world, ruled by reason and mathematics, was being born. Amid this storm, a quiet, solitary boy from a small village would one day stand at the center of a scientific revolution. Isaac Newton, mathematician, physicist, astronomer, theologian, became one of the most influential minds in human history. But his story is not one of peace and perfection. It is a tale of obsession, isolation, rivalry, and revelation. From a lonely farmhouse in Lincolnshire to the halls of Cambridge and the Royal Society, Newton's journey was shaped by a burning desire to decode the mind of God through the language of numbers. It was Christmas Day, 1642, in the small hamlet of Woolsthorpe, England. The land was torn by civil war. King Charles I fought Parliament. Soldiers marched through muddy roads. Fear ruled the countryside. In this chaos, a premature baby was born, Isaac Newton. His father had died months earlier. His mother, Hannah Ayscough Newton, soon remarried, leaving young Isaac to be raised by his grandmother. He grew up lonely, quiet, and withdrawn, always watching, always thinking. Even as a child, he built sundials, miniature windmills, and water clocks. Neighbors whispered that the boy had a head full of strange devices. He preferred books to people, and though his teachers saw his brilliance, they could not have imagined the fire smoldering inside him. Newton grew up during an age of questions. The Renaissance had given birth to humanism and curiosity. Galileo had turned his telescope toward the heavens and seen moons orbiting Jupiter, proof that Earth was not the center of the cosmos. Descartes had proposed that nature could be explained by mathematics, not miracles. The world was no longer divine mystery. It was a machine waiting to be understood. This spirit of inquiry shaped young Newton's mind. He devoured books on alchemy, theology, and mathematics. He read Euclid's Elements, Galileo's Dialogues, and Descartes' Geometry. But he did not simply accept their ideas. He wanted to go beyond them, to find the invisible threads that tied all forces together. In 1661, Newton entered Trinity College, Cambridge. At first, he was just another student, poor, quiet, unremarkable. But when he discovered the works of Kepler and Galileo, something inside him awakened. He began keeping secret notebooks, filled with experiments, questions, and dreams of cosmic order. Then, in 1665, disaster struck. The Great Plague swept through England, killing tens of thousands. Cambridge shut down. Newton returned to Woolsthorpe, isolated, restless, and surrounded by death. Yet in that isolation, something miraculous happened. Those 2 years, known as Newton's Annus Mirabilis, or Year of Wonders, became the most productive period of his life. In his small farmhouse, Newton developed calculus, explored optics, and conceived the law of universal gravitation. He watched an apple fall from a tree and wondered if the same force that pulled the apple down might also hold the moon in its orbit. From that single question, he began to unravel the universe itself. Newton saw himself as more than a scientist. To him, understanding nature was a divine act. He once wrote, "Gravity explains the motions of the planets, but it cannot explain who set the planets in motion." He believed his discoveries were part of a sacred duty, to reveal God's design through mathematics. His equations were prayers in numerical form, and his relentless curiosity was driven not by ambition, but by revelation. But behind this divine vision lay a restless spirit. He was secretive, distrustful, and consumed by his own thoughts. His solitude, once his strength, would later fuel bitter rivalries and personal torment. As England emerged from civil war into the Enlightenment, Newton's mind stood at the frontier between faith and reason, the last magician and the first modern scientist. The world was about to witness how one man's obsession could redefine reality itself. When Isaac Newton returned to Cambridge after the plague, the world seemed reborn, but so was his mind. Sharper, bolder, unstoppable. He began experimenting with light. Using a simple prism, he let sunlight pierce through a small hole in his window shutter. To his astonishment, the light split into a brilliant spectrum of colors: red, orange, yellow, green, blue, indigo, violet. The discovery shook the foundations of science. Until then, scholars believed that white light was pure, divine. But Newton proved it was a mixture of all colors. His experiments, later written in optics, revealed that color was not a property of objects, but of light itself. He showed that the rainbow was not a miracle. It was mathematics at work in nature. But Newton's pride in his findings soon drew enemies. When he presented his ideas to the Royal Society, one man in particular refused to bow: Robert Hooke. Robert Hooke was already a respected scientist, known for his work on elasticity, microscopes, and planetary motion, but he was also jealous, irritable, and fiercely protective of his reputation. Hooke accused Newton of stealing ideas. He argued that Newton's theories about light were wrong, that light behaved as waves, not particles. Newton, deeply sensitive and suspicious, took it as an insult. Their feud escalated. Letters turned venomous. Meetings at the Royal Society grew tense. Hooke's criticism wounded Newton so deeply that he withdrew completely from public life. For years, he refused to publish. He destroyed drafts, burned notes, and sank into isolation. His genius became a fortress. No one could enter, and he would let nothing escape. But the universe would not let him rest. Sometime during his years of solitude, Newton returned to that haunting question: why does an apple fall? He realized that the same invisible force pulling the apple to the ground must also keep the moon in orbit. If the moon was constantly falling toward Earth but never hitting it, then gravity was not limited to the ground, it was universal. He began to calculate. He compared the motion of falling objects with the motion of planets. The numbers aligned perfectly: gravity, a single law governing both heaven and earth. But Newton did not publish his revelation right away. Years passed. It wasn't until Edmund Halley, yes, the same Halley whose name now graces the famous comet, visited him in 1684, that history changed course. Halley asked Newton what kind of curve a planet would follow if the force of attraction was inversely proportional to the square of the distance. Without hesitation, Newton replied, "An ellipse." Halley was stunned. He begged Newton to show his work, and from that request was born one of the most important books ever written. In 1687, Newton published Philosophiae Naturalis Principia Mathematica, known simply as Principia. It was not just a book. It was a revolution bound in leather. In it, Newton laid down 3 laws of motion. 1. An object remains at rest or moves in uniform motion unless acted upon by a force. 2. Force equals mass times acceleration. F equals ma. 3. For every action, there is an equal and opposite reaction. He unified the heavens and the earth under one set of laws, proving that the same physics that moves an apple governs the motion of planets and stars. Hooke, furious, again claimed credit. He insisted that Newton had stolen the idea of inverse square gravity from him. Newton retaliated with silence and precision, removing Hooke's name from later publications. Their feud became legend, and some say Newton never forgave him. But Principia triumphed. It turned chaos into order, transforming science into a system ruled by mathematics. The universe was no longer unpredictable. It was knowable, measurable, divine in its structure. As Voltaire later said, Newton explained the universe. All the rest are but interpreters of his light. Despite his monumental success, Newton remained a solitary figure. He avoided fame, rarely smiled, and never married. His letters reveal a man haunted by inner storms, religious doubt, paranoia, and sleepless nights filled with calculations and prayers. He spent years studying alchemy and biblical prophecy, searching for hidden codes in Scripture. To him, science and faith were not enemies, but twin paths to truth. He once wrote, "The more I study nature, the more I stand amazed at the work of the Creator." Yet that same conviction made him harsh toward those he believed stood in his way. Hooke died in obscurity. Newton, by contrast, rose to glory. By the end of the 17th century, he was the most respected scientist in the world, the man who weighed the stars and measured the motions of the heavens. But his story was far from over. Power would tempt him. and a new kind of darkness would follow. By the late 1600s, Isaac Newton had achieved what few could dream of: immortality through intellect. His Principia had elevated him to near mythical status, but genius alone could not protect him from ambition. In 1696, Newton left the quiet halls of Cambridge and entered the heart of power, London. He was appointed Warden of the Royal Mint, a position that gave him control over England's money supply. At that time, England was drowning in counterfeit coins. Criminals clipped edges from silver coins and melted them down for profit. The economy was collapsing. Newton, armed with mathematical precision and a sense of divine justice, waged war on corruption. He reformed the nation's currency, organizing one of the largest coin recalls in history. But he did more than count coins. He became a detective. Disguised in plain clothes, Newton roamed taverns and markets, gathering evidence against counterfeiters. He interrogated witnesses, tracked suspects, and built airtight cases. One by one, he sent forgers to the gallows. The most infamous was William Challoner, a master counterfeiter who mocked Newton publicly. Newton pursued him relentlessly. After months of investigation, Challoner was caught, tried, and hanged at Tyburn. For the public, Newton was now more than a scientist. He was a symbol of law and order, the man who restored trust in England's currency. But beneath the calm of success, storms were brewing once again. In 1703, after the death of his old rival, Robert Hooke, Newton was elected president of the Royal Society. It was poetic justice. The chair once occupied by Hooke now belonged to the man he had tried to destroy. Yet power changed Newton. The once reclusive scholar became a stern ruler of the scientific world. He controlled publications, decided whose work would be honored, and whose would vanish in silence. To oppose him was dangerous. When the brilliant German mathematician Gottfried Wilhelm Leibniz published his own version of calculus, Newton saw red. He accused Leibniz of plagiarism, claiming he had stolen Newton's ideas from early manuscripts. A vicious dispute erupted, one that divided the entire European scientific community. Newton mobilized the Royal Society itself to investigate, a committee he secretly controlled. The verdict, unsurprisingly, favored him. Leibniz's reputation was tarnished. His health deteriorated. Newton's name, however, grew brighter. But victory came at a cost. He became increasingly paranoid, convinced that enemies were everywhere. He suffered sleepless nights, fits of rage, and long bouts of depression. By 1693, Newton's mental health had begun to unravel. Letters from that time reveal a man trembling under invisible pressure. He accused friends of conspiracy, lashed out at colleagues, and retreated into total isolation. Some historians believe he suffered from mercury poisoning, a side effect of his alchemical experiments. Others think it was sheer exhaustion from years of obsession and stress. Whatever the cause, the great mind that had once mapped the cosmos now turned inward, consumed by shadows. In one letter to a friend, he confessed, "I am extremely troubled. I fear I am fallen into a state of madness," but like a storm passing, Newton slowly recovered, never fully, but enough to return to public life. He buried himself in work and religion, turning away from discovery to seek peace in order and faith. As the years passed, Newton became a living legend. Kings and scholars sought his counsel. He was knighted by Queen Anne in 1705, becoming Sir Isaac Newton. He dined with nobles, led the Royal Society, and lived in comfort at Kensington. Yet the fire of discovery had faded. He no longer sought to understand the universe, only to preserve his image within it. Visitors who met him in his old age described him as kind but distant, his eyes still sharp but filled with melancholy. He spoke often of the past of the apple, of Cambridge, of stars and scripture. He kept 3 locks of hair from his youth in a small box, perhaps to remind himself of the boy who once gazed at the heavens and dared to ask why. In his final years, he lived quietly, reading the Bible daily and writing notes about the end of the world. He predicted the apocalypse might come in 2060, not as a prophecy of doom, but as a mathematical curiosity. On March 20th, 1727, at age 84, Isaac Newton passed away in his sleep. The man who had measured the universe closed his eyes forever. He was buried in Westminster Abbey, Beside kings and poets, a fitting home for a man who reigned over knowledge itself. As the poet Alexander Pope later wrote, "Nature and nature's laws lay hid in night. God said, 'Let Newton be,' and all was light." Newton's story is not just one of triumph, it is a reminder of the cost of genius. He conquered nature, but could not conquer himself. He uncovered cosmic laws, yet battled inner chaos. His brilliance illuminated humanity, but burned him from within. And still, centuries later, his light endures. Every rocket, every orbit, every equation that sends a satellite into space traces back to the man from Woolsthorpe. The boy who watched an apple fall taught the world how to rise. When Isaac Newton died in 1727, the world mourned not just a man, but the birth of a new age. His name had become synonymous with truth, with the very structure of reality. The Enlightenment had arrived. Europe was awakening to the power of reason. Philosophers, scientists, and artists all turned toward a universe now seen as orderly, mechanical, and understandable. Newton's equations became the language of the cosmos. For the first time, humanity believed it could predict the motion of the stars, the tides of the sea, and even the flight of a cannonball, all through mathematics. The mystery of nature was replaced with method. The age of miracles became the age of measurement. Voltaire, the great French philosopher, once said, "If I have seen further, it is by standing on the shoulders of Newton." And for centuries, the world did exactly that. Newton's universe was a grand machine. Every planet, every atom, every gust of wind, all followed the same eternal laws. His mathematics gave humanity confidence that the universe was not chaos, but clockwork. Astronomers used his laws to chart the paths of comets and predict eclipses with astonishing precision. Engineers applied his principles to build machines, bridges, and weapons. Physicists used his equations to explain everything from the motion of waves to the behavior of pendulums. For over 200 years, Newton's physics stood unchallenged. To question it was to question reason itself. He had given humanity not just formulas, but faith that everything in existence could be explained if only we could find the right equation. This idea became the foundation of the Industrial Revolution. Steam engines, railways, electricity, all arose from Newton's mathematical order. Even art and philosophy changed. Painters began to study light as a scientific phenomenon. Philosophers like John Locke and David Hume built theories of knowledge based on observation, the same way Newton had studied nature. He had turned curiosity into a method, and that method built the modern world. But no truth stands forever. By the 19th century, strange new discoveries began to appear, things Newton's equations could not explain. The orbit of Mercury was slightly off. Light seemed to behave both like a particle and a wave. And at speeds close to light, Newton's laws broke down. Then came Albert Einstein. With his theory of relativity, Einstein showed that space and time themselves could bend, that gravity was not a force acting at a distance, but the curvature of space. It seemed as though the universe had slipped its clockwork gears. Yet Einstein never sought to destroy Newton. He revered him. He once said, "Newton, forgive me." Einstein knew that without Newton's laws, there would be no relativity. Every new discovery stood upon the foundation Newton had built. Even quantum mechanics, the study of the tiniest particles, owes its birth to Newton's obsession with precision and measurement. In a way, Newton's vision still rules. For while relativity governs the vast and quantum mechanics the small, it is Newton's laws that guide our everyday world, the flight of a plane, the arc of a basketball, the orbit of a satellite. His universe still moves, steady and elegant, beneath our feet. Beyond the equations, Newton's story is about something even deeper, the human mind's hunger for understanding. He was not born to privilege or power. He was an outsider, a loner, a quiet boy with too many questions. And yet, from that stillness, he touched infinity. His life reminds us that genius is not born in comfort. It is forged in curiosity, isolation, and relentless pursuit of truth. Newton taught us that even the simplest moments, like an apple falling, can reveal the most profound secrets of the universe. He showed that every law of nature begins with a question whispered in wonder. And in doing so, he gave humanity its greatest gift, the courage to ask why. Centuries later, his presence is everywhere. Every spacecraft that navigates the stars relies on his laws. Every engineer, every physicist, every mathematician still walks the path he illuminated. Even when we look through the most powerful telescopes or run the most complex simulations, Newton's fingerprints are there, quiet, invisible, eternal. He once wrote, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. That humility, that awe may be his greatest legacy of all." Because in the end, Newton didn't just define gravity. He taught us how to seek. He turned falling apples into falling stars. He gave shape to the heavens. And he reminded us that the universe is not beyond reach, it's waiting for us to look closer. So next time you look up at the moon, remember it stays in the sky because of a question one man dared to ask in a small English orchard centuries ago. Newton's light still shines in every equation, every experiment, every dream to understand the cosmos. If you believe curiosity still changes the world, then keep exploring, keep questioning, keep falling upward. Because as long as we wonder, Newton's story never ends.